In this section, you'll be learning about transformations in the coordinate plane. Essentially, there's 4 basic transformations that you're going to learn about. The first is reflecting figures across various lines, translating figures in the coordinate plane, rotating figures around a point, which is typically around the origin, by both 90 and 180 degrees, and then dilating figures in the coordinate plane by scale factors. So first, let's just talk about the basic definition of transformations, which is movements of figures in the coordinate plane. In the examples for this table, mostly we'll just be using points to start, but say you had a triangle whose coordinates were labeled A, B, and C. After a transformation, those coordinates get labeled A prime, B prime, C prime. The prime is just an apostrophe, it's just how it's read, but really all it means is that's the new A coordinate, that's the new B coordinate, and that's the new C coordinate after a transformation. If you transformed the transformed figure, then the coordinates would become A double prime, B double prime, C double prime, and you could keep doing that for however many times you transform a figure. So a reflection is a pretty easy form of a transformation. It's when you flip a figure across a line, and you can do it across various lines. The easiest ones are the x-axis or the y-axis. So there's actually formulas for that. So if you wanted to reflect across x, and let's say you had a point whose coordinates were x comma y, when you reflect across the x-axis, the x-coordinate stays the same and the y-coordinate becomes its opposite. And you could see that here if you had like the point 2, 3, and you wanted to reflect across the x-axis. You're flipping that point from here down, and it has to stay the same distance. So it's going to stay in the same vertical line, and then it would have to remain the same distance away from the x-axis, which is 3 spaces. So it'd be 1, 2, 3 down. So that would be your new point right there. And again, if that was point A, then that would be your point A prime. To reflect across the y-axis, if you have a point x, y, and we'll start with our original A point over here, this time if you're reflecting across the y-axis, when you move that point over, it's going to stay the same height, so the y-coordinate is going to stay the same, but the x-coordinate will become its opposite. So this time it needs to stay 2 away from the y-axis, but it's going to stay 3 up. And then, in this case, that would have been A prime. A hint when you're thinking of reflection also is that FL is in the word reflection, so you can think of flip. Translation, SL, translation is a slide. So a translation is what you get when you slide a figure in any direction in the coordinate plane. So if you start with a point XY, and if the x coordinate gets translated by a value of A, you're just adding A, and if the y coordinate gets translated by a value of B, you're adding B. Keep in mind that A could be positive or negative. If A was positive, the figure would be moving to the right. If it was negative, it would be moving to the left. If B was positive, it's moving up. If B was negative, it's moving down. But typically, what you'll see is if you're given, say, that point x, y, you might just be told to translate that figure or that point 2 units up. So you just go 1, 2, and maybe 5 units right, and you go 1, 2, 3, 4, 5. So that would be your new point, and if that was A, that would have been A prime. A dilation is an enlargement or a reduction of a figure, and you're doing this by a scale factor K. So if you wanted to make a figure twice its size, its scale factor would be 2. And one thing I just want to add here is so that if K is greater than 1, I know this is in the wrong box, it's going to be an enlargement. And if K is between 0 and 1, it's going to be a reduction. And the way that you do a dilation is you would take each point of a figure and you would just multiply each coordinate by whatever the scale factor is, and then plot those new resulting points. So here, if this was your triangle and you wanted to dilate that figure by a scale factor of 2, Well, here your original point is negative 2, 0, so that would become negative 4, 0, because if you multiply each by 2. This point right here is 0, 2, so if you multiply each by 2, you'd get 0, 4, and here you'd get 4, 0. So you can see that the red triangle becomes twice as big as the black triangle. But it doesn't really shift position, it's just kind of becoming bigger. Rotations happen around a point. Typically that point for us is going to be the origin. You can rotate a figure 90 degrees counterclockwise, so kind of that way, or you can rotate a figure 180 degrees. The reason they don't put counterclockwise or clockwise on it is because it would end up in the same position anyway. To do a 90 degree counterclockwise rotation, this one you really just need to know the formula for. So if you start with a point xy, what happens is that y coordinate would move to the x spot and actually becomes the opposite, and then the x coordinate takes the y spot. So what that would look like on a graph is, say you have the point A and its coordinates are 1, 2. When you do rotate 90 degrees counterclockwise, that y coordinate's going to come first, but we're going to make it its opposite, so it's going to become negative 2, and then the x coordinate becomes the y. So negative 2, 1, so that would be here. And that would be the point A prime. To do a 180 degree rotation of a point, and we'll start with our original A over here, when its coordinates are x, y, they just become negative x, negative y. So in this case, x was 1, so it's going to become negative 1, y was 2, so it's going to become negative 2. You could actually check that by, so that's right here, this is the 180 degree rotation of the original A. But you could also check that by rotating this by 90, which would say to take the x coordinate, which was negative 2, and move it to the y spot. So that's negative 2, and move the y coordinate, which was 1, move it to the x spot, but also make it negative. So this was a 90 degree rotation of A. Here's a 180 degree rotation of A, and here's a 90 degree rotation of A prime. So just kind of another way to look at it. So we'll do the first transformation together, and then I'll have you try the next couple of transformations on your own, and you can pause and then come back to hear an explanation. So on this one right here, we're trying to translate this triangle down here over the x-axis. So we want to pretend like almost as if you were folding a piece of paper right on this line. Where would the resulting triangle end up? So you can kind of do it two ways. One, you could just do it visually. You could kind of count. You could see that the point B is 1, 2, 3, 4 spaces from the x-axis, so it's going to land 1, 2, 3, 4 spaces away. You could do the same thing with A and C. That's kind of the more common sense way to do it. Or you could apply the formula, which says that every point x, y, when you reflect across the x-axis, becomes x and then opposite of whatever y is. So you could start by listing each coordinate. So the coordinates of A are -6, -6. The coordinates of C are -2, -6. And the coordinates of B would be -6, -4. And if you apply the formula here, that means that A prime is going to equal -6, +6. B prime is going to equal -6, +4. And C prime is going to equal -2, 6. So then you could plot all those points. 1, 2, 3, 4, 5, 6. 1, 4. And -2, 6. And then connect. So that's A prime. Oops. That's C prime, A prime, B prime. And if you actually could fold that over, you would see that those two triangles would land right on top of each other. So you're going to try to perform these transformations. The translation you could actually probably just do by counting each point. Be sure to label your final answer correctly. This 90 degree and this 180 degree rotation, you're probably going to want to use the formulas for. Make sure you label all your resulting points. Pause the video, press play when you're ready to come back and check your answer. Okay, so on the first example of translation, this one's probably the easiest. You can just figure it out by counting. You just take each point and count up 5 spaces, 1, 2, 3, 4, 5, left 3 spaces, 1, 2, 3. Once you have the new figure, it should be the same size. If you could slide this figure back on top, they would match up exactly. And if you look down here, to get from W to Z, it's 1, 2, 3, 4. To get from W prime to Z prime, it's 1, 2, 3, 4. So they should still have the same size. Make sure you label all of your new points as prime, which I didn't there, so that should have been X prime. Down here, I think the easiest way to do this is to apply the formula. So I actually wrote down the formula here, and then I wrote down all the original coordinates in red. Then I applied this formula, which said, take the X coordinate and just move it to the Y spot. So here, 1 became the Y, 3 became the Y, 3 became the Y, 1 became the Y. And then take the Y coordinate and move it first, but also make it the opposite. So 2 became negative 2, 2 became negative 2, 6 became negative 6, and 6 became negative 6. Then you plot all those new blue points over here and make sure you label them appropriately, R prime, Q prime, S prime, P prime. And then your rectangle should still be the same size. We didn't change the size of it, we just moved it. We kind of took this S and pulled it down here, 90 degrees counterclockwise. So you can see the distance between S and R is 2 spaces, the distance between S and R prime is 2 spaces. R prime to Q prime is 1, 2, 3, 4. R to Q is 1, 2, 3, 4. So the fact that the rectangle still has its same size is a good thing. Same thing over here. Again, I started by writing down the formula. So x, y just becomes, both coordinates become the opposite. And then the reds were the original coordinates. And then the blues would be the new coordinates after you apply the transformation. And then here's the resulting triangle down here with the appropriate labels, K prime, J prime, L prime. And you can kind of picture if you could put your pen on J and spin it 90 degrees, it would end up in this quadrant, and then spin it 90 degrees more, it would end up in this quadrant. Again, the sizes all match up, 4 units here, 2 units here, 2 units here, 4 units here. We're good to go with that. So in a second, you're actually going to try these 2 last transformations on your own. To dilate, don't forget that it's either an enlargement or a reduction, and the way that you apply that is you just take each coordinate from each part of the figure and multiply by the scale factor. So in this case, your 4 coordinates, C, D, E, and F, just multiply both the X and the Y by 2, and then draw your resulting picture. On the next example, this is a different type of a reflection because we're not reflecting across the X or Y axis. This time we're reflecting across this line, X equals negative 1. Don't forget that vertical lines are X equals, horizontal lines are Y equals. So the easiest way that you're going to do this is just kind of count. So the R point is 1, 2, 3, 4, 5 spaces from the vertical line, so it would be 1, 2, 3, 4, 5 spaces. And then you just kind of picture if you folded the paper here, what would match up on this side, what would the pentagon be, and make sure to label appropriately. Pause the video, press play when you're ready to check your answer. So on this first one, it could be a little hard to see just because I have so much going on, but first I found each of the new coordinates. And then I plotted the new points with each of the labels. So here's C prime, D prime, E prime, F prime. One thing you can look for is, does this distance become double on the new figure? So here it was 2, 1, 2, 3, 4. And same thing at the top, 1, 2, 3, 4, and it became a distance of 1, 2, 3, 4, 5, 6, 7, 8, so it doubled. And again, this one I just did by counting. So R had been 5, we talked about that. S was 1, 2, 3, 1, 2, 3, that's where S prime would be, and you could do that for each point.